All right, so you read pages 30 and 31. We have the starting temperature, it was negative 15. So I know that's my first value that I'm going to have in my number sentence. Because it's asking you to write two number sentences showing the two different final temperatures. So then I have this change in 25 degrees. Go ahead and share with your partner the two number sentences that you came up with. And Otis, you can go with Eli. Tatiana, why don't you move and go with Hennessy? And then Peyton, we can just work with those two.
Alright. I am ready.
I didn't. It keeps getting higher. So I did negative 15 and the change. But it's I didn't do it. Going down. I did go negative 15.
So I have two temperatures here. I start with negative 15 on both my number sentences. My change is what happens next. Here I have a positive change of 25, and that equals a positive 10. How do I know that's going to be a positive number? Callie?
Because 25 is bigger than negative 15.
I have a greater absolute value here, right? This has a greater absolute value than negative 15. So then down here, I have negative 15 plus negative 25. So if you guys look over here, I'm adding two negatives. And we know that when we add two negatives, we're going to make something even more negative. Okay, so what's the answer to this one? Cam?
Negative 40.
So those are the two number sentences that you would come up with. Here I have a negative plus a positive. I know the answer is going to be positive because my absolute value of 25 is greater than negative 15. And so all I have to do here is find the difference. Here I have two negatives. I almost can treat it like they're positive and then change my answer to negative. Because we know that a negative plus a negative is going to stay negative. It's like adding two positives, except your answer is going to be negative. The absolute value of 40 is the same if they were positive. Questions about those two number sentences? And then the last piece. So how can you predict if your answer will be positive or negative? Who would like to try? Otis?
If the positive number is bigger than the negative number, it's going to be positive. And if the negative number is bigger than the positive number, it's going to be negative.
Awesome. So basically what Otis was saying was, if I have a number sentence like 8 plus negative 6, here I have a bigger positive, right? Plus a smaller negative. You notice I made my n a little small? Because it's not as big as positive. I'm going to get a positive number. But this positive number is not going to be as big as the original positive. So it's a little bit smaller than that. So this is always true. A bigger positive or greater absolute value here than this value will always be positive. Here I have a greater absolute value in the negative. And I'm adding a positive, I'm still going to have a negative value. Okay? And this absolute value will not be as big as your original absolute value. Okay? These are called algorithms. They kind of show you some truths without even putting any numbers in. So today we're going to actually be talking about some of those, but this idea of predicting whether the sum of two numbers will be positive or negative is what we're working on. Okay, we're going to be using that concept today. YouTube, I've uploaded the videos. Obviously, I'm making one right now. But if you guys go to the classroom, and here in the classroom, you can see I have this week's slides there, last week's slides. So if you're missing a warm-up, exit ticket, this is where you go and get that.
Homework too?
homework as well. If I forgot to write down the homework, I click on the slides. Okay, so I can click on like today's slides. And let's say I missed yesterday's homework. And I scroll down to the homework page. And then here on the homework, it will tell you exactly what we did yesterday and what is due. So remember, with exit tickets, warm-up, and homework, doesn't matter if you're in school or not, right? They are expected. And this is where you find them. So I can go back. Also on the Google Classroom, if you scroll down on the stream, okay, you're going to find the YouTube channel. And then when you click on it, it is going to pull up two things that are resources for this unit. Unit 1, Mr. McFarland Accentuate, that is me teaching. And then Unit 1 resources, which is Khan Academy and Math Antics. Okay, both of those are great resources. If I click on this, this is all of the videos that I've uploaded down here in the stream, down below. Okay? And you can find that's in that playlist. So that is about that. And I want to think there was something else I needed to. Oh, tomorrow we will go over the homework, which was your reflection paper. We have a little exercise that we're doing tomorrow for that. Today, you should have grabbed this at the door. Please pull that out. This is 2.1. So up here, basically, this is number 8. It is 2.1, and we're going to call it plus or minus rational numbers. So right now, you're looking at basically 8 things in your index. Keep track of those because that will help you when we go to grading your binder, as well as anytime you have questions, you have a more organized way to look at it. Go ahead and read the notes section up top. So we have this idea of rational numbers have patterns. And some of the patterns are exactly like we were talking about before in an algorithm. A larger positive plus a smaller negative still equals a positive. This is a pattern that happens time and time and time again. Here's another pattern. A larger negative in absolute value terms plus a smaller positive in absolute value terms equals a negative. So, if 5 plus 11 equals 16, then what does negative 5 plus negative 11 equal? Dr. Brian?
Negative 16 because both of them are negative. One of them is negative. I always
Someone want to try to tell me what those algorithms mean? Connor, go for it. What do these two algorithms mean?
Positive plus a positive equals a positive, and a negative minus or plus negative equals negative.
Woo, that was good. Can someone add a detail into that? Tatiana?
A positive plus a positive equals a bigger positive. And
Yeah.
a negative plus a negative equals a bigger negative.
Well, small
Yeah. Yeah, right. Well, it's a greater absolute value negative, right? So this, if we add a negative plus a negative, we know we're going to get an even larger absolute value negative. And we know if we add a positive plus a positive, it's going to equal an even greater positive number, even bigger. So that's kind of why they're shaped like that. And that's exactly what this is. So if you have two negatives, you can almost treat it like it's two positives, except then at the end you need to make sure you have a negative sign. Okay? So why does this help you? It helps me solve because why? Talk to your partner. Why does it help you solve? How does it help you? How does it help you solve?
It helps me solve.
Honestly, I'm not really sure.
Someone want to try here? Eli, how does it help you solve?
So because it gives me a reference and it shows me the algorithms.
Write down your answer. How does it help you solve? Get that down. So it could be, like Eli said, it helps him solve because now he has an algorithm to kind of check his work, right? A pattern, so to say, to like check to be like, hey, did I get an even bigger positive? Did I get an even greater absolute value negative? If he's adding two negatives, he kind of knows what to look for. It's like a guideline, a pattern that he could use. So the second one, what do we notice about what do we notice about 2 that's not in 1? Addie, what do we notice about 2 that's different than 1?
The number sentence doesn't have all positives in it or negatives.
Or all negatives, right? It's either one or the other. So here we have a positive plus a negative, and our negative has a larger absolute value than our positive. So what do we get? A negative. So here we have a negative plus a larger absolute value positive, and what do we get? Positive. So if this equals -6, what does this one equal? Yeah.
Positive 6?
Positive 6. So here we have -5 plus positive 11 equals positive 6. So if you were to make an algorithm for this, what would it be? Tell your partner, what would it be? So I heard a smaller absolute value negative plus a larger absolute value positive is going to equal still a positive, but not as big as the original positive. So it helps me solve because, again, what does this allow you to do? What does it allow you to do? Does it give you like a framework to follow a little bit?
Yeah.
Okay? This is a quick and easy way to check your work. I can go back and be like, okay, small negative plus a large positive should be a smaller positive than this positive. If it is, then I know I'm kind of close. Okay, at least I'm doing the right process and I'm not missing a negative or adding them together when I shouldn't be. So it gives you a method of checking quickly. So it helps me solve because I can use this algorithm to help check my work. Number 3, though. This one's a little different. Look at number 3, Otis. Look at number 3, guys. What's different here? Jayla, what's different?
You're adding 2 negatives.
Okay, I'm adding 2 negatives, and I get a negative, right? We know that when I add 2 negatives, I'm going to even get a greater absolute value negative. Just like adding 2 positives, right? You're going to get a greater absolute value positive. So, but look what happens. What did I do to the numbers? I have -3 plus -4 equals -7. Then how can this help me solve this? -3 2/3 plus -4. Eli, how can this help me?
It can help you because it shows you the what your subtract it shows you what you're doing to -4.
Okay. Addie?
Don't know.
Okay. Could could I just add the integer part of this? Yeah. I could go negative 3 plus negative 4 equals negative 7. But the problem is this is not just integers, right? We have a rational number here. So what do I do with this fraction? Connor?
Would you make the 4 in a fraction also, and then add the 2 fractions?
You don't even have to. Otis?
Could you just put the 2/3 behind?
Yep. In this case, it works. So negatives act just like positives, because if this was a positive 3 2/3 plus a positive 4, you guys know that that is 7 2/3. Well, negatives are exactly the same way when they both are negative, right? So this can help me solve because I can treat these as positive rational numbers and then just make sure that when I get to my answer, that my answer is negative. Because I'm adding negative numbers together. And I know that that absolute value increases just like two positives.
So would it be the same thing if it was like a negative 3 2/3 plus a positive 4? Would it be the exact same thing?
No, it would not. Well, yes, it would. In that case. Okay, so that's a very good question. Callie asked this. She said, what if this was a 3 2/3 plus a negative 3 2/3 plus 4? So now, which one has a greater absolute value?
4.
Positive 4, right? So I know that my answer is going to be positive. Okay? But this is a little bit more difficult, isn't it? Because I know it's not going to be positive 1. It's actually just a positive 1/3. So that's a little bit harder to do. We'll get into this more. Okay, last one. Talk to your partner about number 4. Okay, so here we're going to have a negative number because our greatest absolute value is negative 7.5. We're adding a positive 3. So we know that this value here is going to decrease in absolute value terms. It's going to get closer to 0 because I'm adding a positive 3 to it. So it gets to 4.5. That kind of makes sense. It's like we were at negative 7.5, we add 3, we go to negative 4.5. So how can this over here help us with this when now it's not just 3, it's 3.2?
Understand the point?
Not a bad thought. But here's the thing. If you draw a number line, four, 5, 6, negative 7, and 2, and that half would be in between 8. So you're here. I'm going to add 3, right? So I go 1, 2, 3. So that brings us to the 4.5. But now I have to add this 0.2. So it actually brings me a little bit further, closer to -4. So instead of -4.5, what's 0.2 less of that? Yeah.
4.3.
4.3. So this would equal -4.3. Harder problem. But if you do it in steps, it can sometimes help you picture that everything is the same. I'm going to add the 3, but I'm also going to add the 0.2. And because I'm adding a positive 0.2, I move to the right. Does that help you? It's a positive 0.2. So I keep moving to the right. If it was a negative 0.2, which way would I go?
Left.
I'll go left. I'll go left 0.2. All right. Which then helps you see, should I make this number's absolute value greater, or should I make the absolute value less? Kind of helps you figure that out. Okay, today. You won't see as many of those difficult problems. Those are pretty challenging, but you're going to come across some. Today, here it is. Do your work on your paper on 2.1. We're problem 2.1 on 32 and 33. You are working on A1 through A4, not A1, A4. That's a through sign. And actually, not sure, I just must have bumped it just right. Okay, there you go. So the first one's 10, right? And then it's, does that make sense? Yeah. You probably want to include the number sentence that goes with it.
Okay.
Like kind of just copy those down and then just put equals at the end of them. Does that make sense? Okay. You got that one? Almost. -6. Because only 6 plus 2 equals 8. And so if that one's 6, then what's the one down below? Oh, yeah, positive 6. Yep, that works. Mm-hmm. Well, we got a 2, absolute value of 2, a -8, absolute value of 8. So which one is going to be positive negative? Negative, because this has a greater absolute value. Okay? And you know that this absolute value is going to be less than theirs as well. You know that that negative value will not be as great as well, you got to keep figuring these out. Because I only see 10 negatives.
So you have to do all.
Yes. Yeah, boom, 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 boom. I mean, you can just kind of keep going because I understand, but then you do those two. Those two. for A2? So A2, what do those have in common? What do all of these have in common? Okay, they have the same sign, right? It's like same sign, same sign, same sign, same sign. Right? What about these? Okay, right. So the first one, it's either all positive or negative. And the second one is either positive, negative, or negative, positive. Does that make sense? So you need to write 2 new problems that would fit in group 1.
I'm still on.
Oh, and then 2 new problems that fit in group 2.
I didn't understand that.
I had 2 new problems. Just.
And that would be group 2, right? Yeah. Where you did positive 12, negative 12, negative 2, positive 2. Bingo.
So do I do one for
Yeah, then you could do group 1. I mean, it's pretty easy. You just literally do the same thing except all positive, all negative. No. No. I'm gonna go 5 minutes and we'll talk about it. Try. I don't. That's not what they're asking you to do. You need to think about, so are they equal? Think about how signs, okay. Think about how, if I'm adding a negative, what's that like? Adding a negative is the same as subtracting a, you go the same direction. Okay? If I'm subtracting, or if I'm adding positive, it's the same as subtracting a negative. Okay, that's what you need to think about. It's these rules right here that you need to think of, because they're not changing the numbers, they're changing the signs, right? Mm-hmm. All they want you to tell it is that equal, is it not? Does that help you, Callie?
Not really, but
D2 is good. I like it. So think about, I want to see if you can't get messy with that. Think about the signs and write them down and say, okay, is this the same? So, okay, is this the same? Okay, these are equal. The reason why is adding a negative is the same as subtracting a positive. That's what they're asking you. Is that R? Now they're making it a little bit flashier because they have like fractions, but the fractions are the same.
mm-hmm. So they would be equal.
Put it down and then go check. See how you do. I'm going to go over to you. Yep, that's those are algorithms, right? These are these are algorithms. So you have that give you, right? They're formulas that you can follow.
Does this want us to do this?
You just no. You what's the algorithm here, and what's the algorithm there? So basically, they're using 2 algorithms. Totally. Because, let's see, this is a positive plus a negative. Okay, and I would make your P a little bit bigger than that N. Okay, and it equals a smaller positive than the one you started. Perfect. Yeah.
Let's take eyeballs in 15 minutes. Should we go?
They'll announce it.
Okay.
Just a little.
Just a little.
Just a little. Oh.
That's the under-exaggeration of your.
She like stabbed me in the heart, rip out my soul. Didn't like that.
Abby! I mean, I don't either,
Shameful.
but say it,
Man.
Abby, it's okay.
Maybe she meant just that 1 millisecond. It was the first time. She didn't like that. But Tatiana, you're so good at it.
I'm sorry, I'm not good at math.
Yeah.
Don't put the wrong thing in your brain.
Sorry, you are. I work with you 2 periods a day sometimes. You alright? Good. It doesn't make sense how changing the signs is the same thing.
But yet they're not changing. They're just making them the opposite because it's still D2 is still positive.
Right, so you have positive, positive, right? Negative, adding a negative, negative. Same thing. So good. I love that. I like how they make you guys. D4 is the harder one, honestly.
Oh, yay.
Because you have to explain how you figure that out.
Why do people want to explain stuff?
I don't
Come on, no.
stuff. I am?
Okay, well, no, you're not. You're thinking out loud. Do not think out loud. Algorithms. So algorithms are what I was writing over there. Like if I have a large positive and I add a small negative, I know my answer is going to be positive. Right? So algorithms are formulas, okay, that help us solve problems, okay? And if I have a large positive plus a small negative,
Okay.
this positive is not going to be as large as that.
So we just need to write one of those for each of these problems.
No, you just need to tell me 2 algorithms that they've used, I think is what they ask you.
For B3?
Okay, volleyball girls, pack up your stuff. Hey, your exit ticket is online. Okay, remember that.
What if we don't have internet?
Get on a smartphone. Google Drive. That's not true.
I swear I do not have
You do not. True
My
statement.
phone has a flip phone.
True statement.
Thank you. I'm not kidding.
Cameron.
I have to some other stuff.
Ah.
Easier. That was easier than the first one.
How so?
Because technically, we already learned that old lady easier because of the negative property in addition. I don't know the rest of numbers, but they're always the same. And then the D2, it explains D2 because that way you can talk about them still the same and they're equal.
That's why I've been telling you guys. That's why I do not want you to write subtraction anymore, because then it's not community.
And then if you write addition, you can swap
Addition, you can swap them wherever you want. Yep. Need help? Okay, keep working. You got it. It's perfect. Yeah. Because basically what I'm doing is it's like, it would be like this. What is 0.00 minus 0.35? Exactly, right? That's basically what it is. Does that make sense, Otis?
Yeah.
Oh. Yeah. Nice. Good work. So describe an algorithm that they've used.
So just
They described a positive plus a positive. What does that equal?
all math, or just want to describe to kids.
Yeah. So if you take a positive and you add another positive, what do you get?
Everyone's calling.
Good.
Yeah, everyone's going.
An even greater positive. If I take a negative and I add a negative, what do I get?
Football.
Yes, an even smaller, a greater absolute value, right?
My mom used to be better, but
Good.
Okay.
Those are algorithms.
So we just say we just say a couple of those for each one.
Yeah. Bingo. Good. What are you doing now?
Marveling that I was correct.
Did you answer D4?
Yeah.
Okay. In D4, did you restate the question?
Yes.
Okay. Did you use mathematical vocabulary?
Yes.
Did you use complete sentences?
Yes.
And then did you support your thinking with a
I don't
graph
sort
or
of.
kind of, but not really? A little. Yeah. Remember, those four things are going to constantly, like that's when you do an open response, that's why it's fast. Restate. And that's how the reflections are graded. Yeah. So what do you have, B2? So are they both negative?
Yes.
I'm adding two negatives. So what's going to happen to my absolute value?
-5.
It's going to get greater, right? It's going to increase. So it's like adding positives. So if I add 5 plus 3, okay, it's 8. And then 1 plus 3 is
Oh, right, 3.
1 plus 3, 4, and then my 5 comes over.
Okay.
Right? You remember that? Okay. Did you just check some of your work?
Dying.
Guys. All right, guys. Put away this. This is day 1 of 2 days. We will come back to this tomorrow. Okay, we'll finish up. There's even more problems that get more complicated. And we'll talk more about negatives and algorithms tomorrow. Okay. Here it is. There it is. Okay. On your planner, on page 44, 3, 4, 11, pretty straightforward. 14b is a little more difficult. But it's not, it's just something that we haven't had a lot of instruction around. But I think you guys are going to be able to do it.
So page 34, problem 11.
3, 4, 11, 14b. If this is coming quite easy to you, and it'll probably take you 6 to 8 minutes. If it's a little bit more challenging, it could be around 12, 13 minutes. So remember, if you're ever confused about what to do, write down everything you know about a problem. Just start writing it down. That tells me you actually spent time thinking about it. You can't write IDK. That gives you 0 points.
I don't know.
0 points. Boom.
Beautiful.
Okay? You get nothing. Okay? And so, remember, when you don't know, when you're not sure how to do a math problem in here, you write down everything that you do know about it. Okay. You got that in your planner? Exit ticket. Write down an algorithm and an example number sentence of your algorithm.
Algorithm. Like.
Just like you had to do, okay, in A3. Yep. Okay? Because algorithms help us do this. Predict whether the sum of two numbers is going to be positive or negative. That's why they're helpful. If I know that I have two positives, I'm going to get an even greater positive. That at least gives me an idea of how to check my work, to a certain extent. If I know I have a greater negative and a smaller positive, well, my negative is a greater absolute value than my positive, I know my answer is going to be negative. And I know the value of that absolute value of the negative answer is going to be less than the negative I started with. Once you have that down, you may have it. See ya later.